Hello out there, welcome to this tutorial again on BECE Mathematics Preparatory lesson. It's a revision video for BECE, JSCE and equivalent, and this is part 2. Check the description section of this video on our YouTube channel Uninab Resources to get part 1 of this video. This is brought to you by Uninab Resources. Visit our website www.uninabresources.com. So we start with the first problem of this lesson. For problem 1, how many vertices V and edges E has a cuboid? So we have the options there. In the solution of this problem, we will have to look at a cuboid. So we give us a skeletal picture of a cuboid. This is a cuboid. So we start with the vertices of the cuboid. What is a vertex? Vertex is the singular form of vertices. A point where two or more lines meet. Like this point here, we have this line meeting with this line here and this line. So there are 3 lines that meet here. So this is called vertex. And we are going to count the number of vertices we have in this cuboid. So this is 1, 2, 3, 4, 5, 6, 7, and 8. So we have V equal to 8, which means we have 8 vertices in a cuboid. Now the edge of a cuboid is as good as saying the line, that is a line joining 2 vertices. So we can see now that this is an edge of the cuboid. So we are going to count the number of edges we have here, that is counting the number of lines we have in the cuboid. So we have 1 here, this is 2, this is 3, this is 4, we have a 5, 6, 7, 8, 9, 10, 11, and 12. So there are 12 edges. So we say E equal to 12. So we say V equal to 8, E equal to 12. And the option there is option C. And that's the end of solution to problem 1. We go to problem 2. For problem 2, calculate the area of a circle of radius 3.5 centimeters. Take pi to be 22/7. So finding solution to this problem, we need to state the area of the circle to be pi r squared, where pi is 22/7. Our radius here is 3.5. We would like to work with a fraction, so that we have 3.5 as 3.5, and 3.5 as improper fraction is 7/2. So that the area of the circle will be 22/7 times 7/2 times 7/2. Since it is r squared, so we have it as 7/2 times 7/2. This 2 here goes 1, 2 here goes 11, 7 here 1, 7 here 1. So we are left with 77/2. 77/2 as mixed fraction is 38/1/2, and as decimal is 38.5 squared centimeters. And we check the option. So the option here is option A. This is the end of solution to this problem. So from here we go to problem 3. For problem 3, the area of a circle is 154 squared centimeters. Calculate the circumference of the circle. We know to calculate the circumference of a circle we need the radius, and here the radius is not given, but only the area of the circle is given. So in finding solution to the problem, we have to use this area to find the radius of the circle. Then from there we will use the radius to calculate the circumference of the circle. So from the formula of a circle, we know is pi r squared, and we are given the area to be 154. So we substitute the area and pi into this formula, so that we now have 154 equal to 22 over 7 times r squared over 1. So we cross multiply. Before then, 22 times r squared gives 22 r squared. So cross multiplying, now we have 154 times 7. 154 times 7. So we divide both sides by 22, so that we have r squared equal to 154 times 7 over 22. We know 22 times 7 times 2 is 14, right? 4 carry 1. 7 times 2 is 14 plus 1, 15. Since 22 times 7 is 154, we say 22 goes into 22 gives 1, and 22 goes into 154 gives 7. So 7 times 7 gives 49, and our r is equal to 7. Finding the square root of 49, that gives 7 centimeters as the radius. Now we can go ahead to calculate the circumference of the circle. Now the circumference of a circle is 2 pi r. So we've gotten our r, and we already have pi. So we now have it as 2 times 22 over 7 times 7 over 1, since our radius is 7. 7 cancels 7 here. 2 times 2 gives 44 centimeters, and that gives the circumference of the circle, which gives option C. And we are done with problem 3. We go to problem 4. For problem 4, calculate the perimeter of a regular octagon with edges 2.8 centimeters. So meaning the sides of the octagon is 2.8 centimeters. We know that an octagon is an 8-sided polygon, and for it to be regular, it means all the sides are equal, all the angles are equal. So to find the perimeter of this, we just take the side and multiply by 8. We now say the perimeter of the octagon is 8e. That's 8, which is the number of sides, multiplied by the edge, the size of the edges. So we have it as 8 times 2.8. What you do is we multiply it out. Later we now apply our point. So we say 8 times 8 is 64. We write 4 carry 6. 8 times 2 is 16 plus 6, 22. So we have it as 22. Since this is one decimal place, so we just count one digit and place our decimal point. We have our answer as 22.4 centimeters. And that is option D. And that's the end of solution to problem 4. We go to problem 5. For problem 5, a square and a rectangle have the same perimeter. If the area and breadth of the rectangle are respectively 32 squared centimeters and 4 centimeters, calculate the area of the square. To find solution to this problem, we are given the area of the rectangle and its breadth. So we can use the area and the breadth to calculate the length of the rectangle. And since the rectangle and the square have the same perimeter, we can then find the perimeter of a rectangle, which is equal to the perimeter of the square. From there, we'll be able to calculate the length of the sides of the square, which will help us to calculate the area of the square. Okay, so we go. Now we use the area of rectangle and the breadth to calculate the length. So we know the area of a rectangle is length times breadth, and the area is 32 The length is not given, so the breadth is 4, so is equal to 4L, and L is 32 divided by 4. Dividing both sides by 4, that will give us 8. And now we calculate the perimeter of a rectangle, which is 2 into L plus B. Now we have the perimeter to be 2 into 8 plus 4, since the length is 8 and the breadth is 4. So 8 plus 4 gives 12 times 2 gives 24 centimeters. The perimeter of the rectangle is 24 centimeters. The perimeter of the square is also 24 centimeters. So they have the same perimeter. So that from here, we know the formula for finding the perimeter of a rectangle is 4L. So this is 4L, that's the length of the square, is equal to 24. Dividing both sides by 4, we have the length of the square to be 24 divided by 4, which gives 6. And now the area of a square is L squared, and that gives 6 squared, which gives 36 squared centimeters, and which corresponds to option E. And that's the end of solution to problem 5. We go to problem 6. For problem 6, calculate the area of the triangle below. The area of the triangle is base times height over 2. Now the base here is 25 and the height is 11. So we said area equal to 25 times 11 divided by 2. 25 times 11, oh god, this is 25 here, then you place the 25 one step before the first 25, that's it, and we add here. This is the best way to do this, so don't ask me how, multiply it out yourself, you see it. So we are adding 5, 7, 2. If I have 22 times 11 now, I can just say 22, then 22 here. 88 times 11, 88 here, 88 here, then I add. So I'm there. So we are dividing by 2. 2 divided by 2 is 1. 7 divided by 2 it gives 3. Remainder 1. That will give us 15 divided by 2 gives 7. Remainder 1, and 1 over 2 is 0.5, so we have it as 0.5 squared centimeters. So the solution to this problem is 137.5 squared centimeters, which corresponds to option C, and that is the end of solution to problem 6. So we now go ahead to problem 7. For problem 7, calculate the area of a trapezium, height 14 centimeters, and its parallel sides are 12 centimeters and 8 centimeters long. And in our solution, we are going to state the area of a trapezium. The area of a trapezium is A plus B times height divided by 2. A plus B. A and B are the parallel sides, and the height is 14 centimeters. So substituting into this formula, I have 12 plus 8 times 14 divided by 2. I can just say 8 plus 12 is 20. 20 times 14 divided by 2. So 2 goes here, 1. 2 goes into 20 gives 10. 14 times 10 is 140 squared centimeters. And 140 squared centimeters is option C. So we have option C as the correct option to this problem. And this is the end of solution to problem 7. So we go to problem 8. Problem 8. Calculate the total surface area of a solid cylindrical object of height 13 centimeters and diameter 14 centimeters. Okay, so in our solution, we are meant to calculate the total surface area of a cylinder. We need to take a look at the cylindrical object. Since it is a solid cylindrical object, it means the top is covered, the bottom is covered. And for this solid cylindrical object, there are three surfaces. The two circular faces. Since the area of a circle is pi r squared, so the two circular faces will be 2 pi r squared plus the curved surface, plus the area of the curved surface, and the area of the curved surface is 2 pi r h. So that's the formula we are going to use to calculate the total surface area of the solid cylindrical object. And for your information, if the cylindrical object is open at one end, you know that it is affecting the circular face. Therefore, instead of 2 pi r squared here, we have pi r squared. And also, if both ends are open, that is a hollow cylindrical object, to calculate the surface area, we are only interested in only the curved surface area, which is 2 pi r h. And now we can factorize this formula. So 2 pi r is common, so we have 2 pi r. So remove 2 pi r here, we have r. Remove 2 pi r, we'll be left with h, so that will be plus h. Now we substitute in the values of pi, radius, and the height. Our height is 13, our radius will be diameter divided by 2, which is 7, and pi will be taken as 22 over 7. So this is going to be 2 times 22 over 7 times 7 over 1 into 7 plus 13. So this 7 cancels the 7. 2 times 22 gives 44. 7 plus 3 gives 20. That will be 44 times 20, and 44 times 2 is 88. Then we just add the 0 squared centimeters. So the total surface area of this solid cylindrical object of height 13 centimeters and diameter 14 centimeters is 880 squared centimeters, and that is option B. And that brought the solution of problem 8 to an end. We go to problem 9. For problem 9, calculate the capacity in liters of a rectangular tank measuring 1.2 meters by 1 meters by 0.7 meters. To find the solution, we have to find the volume of the tank first. And the volume of the tank is length times breadth times height. So our length is 1.2 meters, breadth is 1 meters, and the height is 0.7 meters. So we convert all this to centimeters, so that our length is 1.2 meters, which is 120 centimeters, and the breadth is 1 meters, that will give us 100 centimeters. And our height is 0.7 meters, and that will give us 70 centimeters. So the volume of the tank now will be 120 multiplied by 100 multiplied by 70. I can quickly say 12 times 7, which gives 84. Then I add the remaining zeros. I have 4 zeros remaining, so 1, 2, 3, 4. That will give us 840,000 cubic centimeters. Now, to calculate the capacity of the tank, it's going to be dividing by 1,000. So we say 840,000 divided by 1,000, which gives 840 liters. This is because 1,000 cubic centimeters is equal to 1 liter. So where we now have 840,000 cubic centimeters, so that will just be 840 liters. and 840 liters is option C. And that's the end of a solution to this problem. We go to problem 10. For problem 10, how many lines of symmetry has a square? We need to get the square and see what is a line of symmetry. A line of symmetry is a line that divides a shape into two equal halves or into two congruent parts. So we look at this square. Since all the sides are equal, the first line of symmetry, this line divides it into two equal rectangles. Also vertically, it divides into what? Two equal rectangles here. And since they are equal, we can also divide diagonally. We divide these into two equal triangles, as two equal isosceles triangles, and the same way to the other side, two equal isosceles triangles. So we have 4 lines of symmetry. So that's all for problem 10. We go to problem 11. For problem 11, given that the triangles below are similar, calculate AC. The triangle below are similar triangles. We are meant to calculate AC. This is AC here. For similar triangles like this, we need to state these triangles in the correct order of their similarities. So we just pick one. Let's say triangle XYZ, XYZ, and I'll see which ones are equal to the other. So like here now, X is this and is equal to this B. So this, we now say this is similar to triangle B, and Y is equal to C. Y is equal to C here, so it will be C, and invariably A is equal to what? Z. So we now have it as what? A. So in the correct order of their similarity, we have stated triangle XYZ to be similar to triangle BCA. And in a similar triangle, the ratio of their corresponding sides are equal. So since the ratio of their corresponding sides are equal, we can say XY, that is the first 2 letters, divided by the first 2 letters here, that's over BC, is equal to YZ, that is the last 2 letters, which is corresponding to the last 2 letters here, over CA, is still equal to first and last letter, that is XZ, over BA. So this is it, and we can combine these ratios to find any of the unknown sides in the triangles. So what is XY? Line XY is 8 centimeters, and line BC is 6 centimeters, that's over 6, is equal to line YZ is 4 centimeters over line CA, that's what we are looking for, that's over CA. And since we have gotten the ratio connecting the ones we are looking for, we can stop here. Although XZ is not given, BA is not given, so we stop here. If we make CA the subject of the relation, which is the same thing as AC, we have it as 6 times 4, which is 24, divided by 8. Is 8 goes into 8 gives 1. 8 goes into 24 gives 3. So AC is equal to 3 centimeters, and that is option E. So that's the end of solution to problem 11. We go to problem 12. For problem 12, find the value of x in the triangle below. And this is another problem on similar triangles. because we have two triangles here, the smaller triangle and the bigger triangle. So to solve this problem, we are going to state the triangles in the correct order of their similarities. So we start with the larger triangle, that's triangle CDE. CDE is similar to triangle. Our usual method is to see which angle is equal to C, which angle is equal to D and E in that order. So since this C is common angle to both triangles, so we have C equal to C, and D is equal to Q. The angle here corresponds to this angle here, since these two lines are parallel. So we have D to be equal to Q, and invariably P is equal to E. So we have CDE is similar to triangle CQP in the correct order of their similarities. Now we said the ratio of their corresponding sides are equal. So we have a CD over CQ is equal to DE over QP, and is equal to CE over CP. So we now substitute in the values of CD, CQ and the rest. So substituting CD is 10 plus 5, which gives 15. CQ is 10, that will give us over 10, is equal to DE is X over 4. QP is 4. And we might not need to go further for this. So 15 over 10 is equal to X over 4. So cross multiplying and making X the subject of the formula, we have X to be equal to 15 times 4 is 60 over 10. And 10 goes here 1. 10 goes into 60 is 6. So X is equal to 6. And that gives option D, which brought the solution to the problem to an end. We go to problem 13. For problem 13, how many square tiles of sides 45 centimeters are needed to cover a floor with dimensions 3.6 meters by 2.7 meters? To find solution to this problem, we have to find the area of the floor and the area of a tile, so that when we divide, we know the number of tiles that will be sufficient to cover the floor. So the number of tiles will be area of the floor over area of the tile. So area of the floor is length times breadth, since it is a rectangular floor, and that will give us in centimeters. We have to work in the same units. So changing this 3.6 meters to centimeters, I have it as 360 times 270 divide by 45 times 45, since a square is L squared. So L squared, 45 squared is 45 times 45. I can go with 9 here, 5. 9 goes into 360 is 40. 9 goes into 45 is 5. 270 divided by 9 gives 30. Now 5 can still go. 5 goes here 1. 5 here 8. 5 here 1. 5 here 6. And 8 times 6 is 48. So the number of tiles needed to cover the floor is 48, and that gives option E. That's the end of solution to problem 13. We go to problem 14. For problem 14, the ratio of volumes of two similar cones is 108:32. What is the ratio of their radii? So here we are given the ratio of volumes to be 108/32. A ratio can be expressed as fraction. And you see that this ratio is not in their simplest form. So the best thing is to divide both sides. 4 can go here to give us 8, and 8 is a perfect cube. So we can say 108 divided by 4, that will give us 27 over 8. So that is the simplest form of this ratio. And now the ratio of their radii will be cube root of 27 over 8. Cube root of 27 is 3 and cube root of 8 is 2. So the ratio is 3:2, and that is option C. That's the end of solution to problem 14. We go to problem 15. Problem 15. The ratio of height of two similar cylinders is 5:3. If the total surface area of the smaller cylinder is 135 square centimeters, calculate the total surface area of the larger cylinder. This is still similar shapes. Now, what we do is the ratio of their height is 5/3, and we need to find the ratio of their areas. So the ratio of their areas will be 5 squared over 3 squared. If you are looking for the ratio of their volume now, it will be 5 cube over 3 cube, and that will give us 25/9. And now we are going to use this ratio of their area to find the second area given the value of one area. So since we are given the smaller area, let's be the bigger area be A. So that will be A over this area of the smaller cylinder is equal to 25/9, making A the subject of this relation by cross product rule. That will be 25 times 135/9, and 9 goes here 1, 9 goes into 13 is 1, remainder 4 in 45 is 5. That will give us 25 times 15, that's 250 plus 125. Wow, how did you get this? This is mental mathematics. What I did is, since 15 is 10 plus 5, I said 25 times 10 is 250, then plus 25 times 5, which gives 125, and I am there. I just add, this is 5, this is 7, and this is 3, and I have my answer as 375 squared centimeters, which represents the total surface area of the larger cylinder, and that corresponds to option A. And that's the end of solution to problem 15. We go to problem 16. For problem 16, the scale of a map is 1 centimeter to 8 kilometers. What is the actual distance between points P and Q if the distance on the map is 13 centimeters? Oh, very simple. And since 1 centimeter is equal to 1 kilometer, so the actual distance, if it is 13 centimeters, will just be multiplied by 8. 1 centimeter is equal to 8. 2 centimeter is 8 times 2. 3 centimeters, 8 times 3. 4 centimeters, 8 times 4. So 13 centimeters will just be 13 times 8. And 8 times 3 is 24. You write 4, carry 2, 8 times 1, 8 plus 2, 10. So the actual distance is 104 kilometers. And that's option C. We are done with problem 16. We go to problem 17. What is the name of the line that connects 2 points of the circumference of a circle? Problem 17. What is the name of the line that connects two parts of the circumference of a circle which does not pass through the center of the circle? So we have the options. To find solution, we quickly look at lines of a circle. We have this circle with center. If you draw a line from the center to any part of the circumference, that will give us a radius. If you draw a line from one part of the circumference to the other part of the circumference, and the line passes through the center of the circle, we call it the diameter. And if you draw another line from one part of the circumference to the other part of the circumference, and does not pass through the center of the circle, we call this one as chord. So these are the three straight lines we have in a circle, and that is what the question is asking. What is the name of the line that connects two parts of the circumference but does not pass through the center of the circle? So it is chord, and that is option D. That's the end of solution to problem 17. We go to problem 18. Which of the following is complementary to 37? Two angles are said to be complementary if their sum gives 90. And remember, if their sum gives 180 degrees, it means they are supplementary angles. So to calculate that now, we said two angles are complementary if their sum is 90 degrees. So to get the complementary to this, we say 90 minus 37, which will give us, this is 10 minus 7 gives 3. 8 minus 3 gives 5, and that's 53 degrees, which is option E. We are done with problem 18. We go to problem 19. For problem 19, calculate the value of x in the diagram below. Calculate the value of x in the diagram below. Now to do that, we need to calculate this angle, which is alternate to this angle, since these are parallel lines. This and these are parallel lines, so we name this one A, so that A is equal to 180 degrees minus 126 degrees, because they are on a straight line. So we call them angles on a straight line, and that will give us 54 degrees. So which means if you call this one B, B is equal to 54 degrees. So we say they are alternate angles. A and B are alternate angles. So to get the value of x now, B plus x is 360 degrees. We can then say x is equal to 360 degrees minus 54 degrees. Our reason being angles at a point, and that gives 306 degrees, which give option E. And that's the end of solution to problem 19. We go to problem 20. Problem 20, the angles of a quadrilateral are m degrees, 2m plus 24 degrees, 2m degrees, and 3m degrees. What is the value of m? So we have options for the value of m. We have to solve this. The sum of angles of any quadrilateral is 360 degrees. So what we do, we are going to add the four angles. That's the m plus 2m plus 24 plus 2m plus 3m is equal to 360 degrees. The sum of angles of any quadrilateral is 360 degrees. So m plus 2m gives 3m, 5m, 8m. That's 8m plus 24 is equal to 360 degrees. Taking this to this side, 8m is 360 degrees minus 24. And that will give us 336 degrees. M is 336 degrees divided by 8. We can pick two digits. 33 divided by 8 is 4 remainder 1. That's 32. And 16 divided by 8 gives 2. Therefore, m is 42 degrees, which is option A. That's the end of solution to problem 20. We go to problem 21. For problem 21, find the value of the angle marked Y in the diagram below. So to find this, we again know that the sum of angles of a triangle is 180 degrees. So we are going to add all this, equate it to 180 degrees. That will be 2y plus 3y plus 4y is equal to 180 degrees. The sum of angles of a triangle. Now we add this. 2 plus 3 gives 5, that's 9y is equal to 180 degrees. Dividing both sides by 9y is equal to 180 divided by 9. And 18 divided by 9 is 2, so y is equal to 20 degrees. And that is option D. That's the end of solution to problem 21. We go to problem 22. Find the value of x in the diagram below. Again, we know that this is a straight line, and angles on the straight line sum up to 180 degrees. Since this is already 90 degrees, it means 2x and 3x are complementary angles, so that we now have it as 2x plus 3x is equal to 90 degrees. The reason still being angles on the straight line, which is 180. Since this is 90 degrees, so the remaining two angles are complementary. They sum up to 90 degrees. This gives 5x is equal to 90 degrees, and x is equal to 90 divided by 5, which gives 18 degrees. And that gives option C. And that is the end of solution to problem 22. We go to problem 23. Problem 23, find the value of k in the parallelogram below. Did you know that opposite angles of a parallelogram are equal? That is the property of the parallelogram we are going to use. So we will be able to find this angle first. So we find this angle, call it A. So we say A is equal to 180 degrees minus 53 degrees. That is angles on a straight line, and that gives 127 degrees. And we said opposite angles of a parallelogram are equal, therefore k is equal to 127 degrees. The reason being opposite angles of a parallelogram, and that gives option E, which brought the solution to the problem to an end. We go to problem 24. For problem 24, we have to express north 30 degrees west as 3-figure bearing. North 30 degrees west as 3-figure bearing. We need to sketch this. So we have our 4 cardinal points. North, this is north 30 degrees, so we have 30 degrees. And to the west, that's the line there. And in 3-figure bearing, we start from the north and move clockwise until we get to that line. So we are looking for this angle here. Let's call it a theta. So since theta plus 30 is 360, we will say theta will be equal to 360 minus 30 degrees. That's angle at a point. That's angle at a point, which gives 330 degrees. So therefore we now said north 30 degrees west is equivalent to 360 degrees as 3-figure bearing, and that gives option E, which brought the solution to this problem to an end. We go to problem 25. For problem 25, still on bearing, express 230 degrees as a compass or acute angle bearing. So we want to express it using the 4 cardinal points. So again, we are going to sketch the diagram. So this is north, starting from the north pole, we move clockwise until we get to this. This place is 180, and the 230 will be somewhere here. We have it as 230. We join the line. We need to calculate this angle between the south and this line. Well, let's call it theta. Theta will be the 230 minus the 180. So 230 minus 180 gives 50 degrees. Therefore, 230 degrees is equivalent to, this is south, 50 degrees to the western direction. So we have it as south, 50 degrees west. And that's it. South 50 degrees west is option E. And that's the end of solution to problem 25. We go to problem 26. The bearing of A from B is 125 degrees. What is the bearing of B from A? Still on bearing and distances. We are going to sketch this. So the bearing of A from B, we start our diagram from B. We start all our diagram from B. 125 degrees, starting from the North Pole. You move, this is 90. It will be between south and east. So we go, it stops here. That's 125 degrees. We then draw the line, and this is 100. We call this one theta. We can say theta is 180 minus 125. That will give us because angles on a straight line, that gives 55 degrees. So we have our point A here. This point A with the cardinal point, which means this angle here is equal to this angle. That's 55 degrees. And now to calculate the bearing of B from A here now. We are meant to start from the North Pole and move clockwise until we meet the line joining A and B. So this is going to be the bearing of B from A will be 360 degrees minus 55 degrees, since that is angle at a point, which will give us 305 degrees. And that's option D. And that's the end of solution to problem 26. We go to 27. Problem 27. What is the size of each interior angle of a regular hexagon? For a hexagon has 6 sides, so n is equal to 6. We know that the sum of interior angle is n minus 2 times 180, or 2n minus 4 times 90 degrees, whichever. To get the size of each interior angle, we need to find the sum of interior angles first, then divide by the number of sides to give us the value of each of the interior angles. So since our n is equal to 6, so we have 6 minus 2 multiplied by 180 degrees. That's 4 times 180 degrees, which gives 720 degrees. So that each interior angle now will be 720 degrees divided by 6. So that will give us 120 degrees. And that gives option E. And that's the end of solution to problem 27. We go to problem 28. Problem 28. A regular polygon has each of its interior angles 144 degrees. How many sides has the polygon? So we have the options there. To find solution to this problem, we let n be the number of sides. Now we need to know certain things, that if you have interior angle and the corresponding exterior angle are on a straight line, so since they are on a straight line, their sum is 180 degrees, so that we now see that this I and E are on a straight line, I and E on a straight line. So we come up to say I plus E is equal to 180 degrees. And if you know that we can now say E is equal to 180 degrees minus 144 degrees. That gives 36 degrees. Since we have each of the exterior angle to be 36 degrees, and we know that the sum of exterior angles of any polygon is 360 degrees, we can now say 36 times n is equal to 360 degrees. Since the polygon is regular, all the sides are equal, all the angles are equal, so that n will be equal to 10. And that's option A, which brought the solution to problem 28 to an end. So we go to problem 29. Problem 29. How many sides has a polygon if the sum of its interior angles is 10 right angles? In this case, what we do is, since the sum of the interior angles is 10 right angle, that is, a right angle is 90 degrees times 10, 900. So we say let the number of sides be n, and we know SI is equal to n minus 2 times 180. Since the sum of the interior angles is 900, we say 900 is equal to n minus 2 times 180. Expanding this, we have 900 equal to 180 n minus 360. Then making n the subject of the formula, we have 180 n is equal to 900 plus 360, so that we have 180 n is equal to 1260. Then dividing both sides by 180, n is equal to 1260 divided by 180, and that gives 7. So if you simplify this, you will have 7. And that's the end of solution to problem 29, which is option C. We go to problem 30. For problem 30, find the value of u in the diagram below. These are exterior angles. We have been informed earlier that the sum of exterior angles of any polygon is 360 degrees. So we'll add up all these exterior angles, equate it to 360 degrees, solve the equation, and we'll get there. So that's going to be sum of exterior angles of any polygon is 360 degrees. So we have 4u plus 4u plus 3u plus 4u plus 3u is equal to 360 degrees. 8, 11, 15, that's 18u is equal to 360 degrees, and u will be equal to 360 divided by 18. U is 20 degrees, and that's option D. This is the end of solution to problem 30, and this is its highest we can take in this part 2. Thank you for watching. Please like and share this video. Remember to subscribe to our YouTube channel. Check the description section of this video on our YouTube channel to get link to part 2 and link to the first part of this video. Until we come your way again, goodbye.